Hello and welcome to Dr. D. Patil Vidyapit Center for Online Learning. Learners, today in this session we are going to learn about unit number 10, that is model boosting and model selection. Before we proceed to the session, let's look at the agenda for the session. The topics which are going to be covered in this session are introduction to k-fold cross validation. What is the process of k-fold validation? What are the advantages of k-fold cross validation technique? Choosing the value, how to choose the value of k-fold validation, and then we conclude the session with the summary. So, let us start with the introduction to cross validation, that is, what is cross validation? Basically, a cross validation is a technique which is used to evaluate the model's predictive performance. So, basically the cross validation is a technique which is used to evaluate the performance of predictive models. So, if you want to measure the performance of the predictive model, then we use the cross validation technique. So, k-fold cross validation is one of the technique which is used for evaluating the performance of a predictive model. So, k-fold cross validation is a specific type of cross validation technique that divides the entire data into k equally subsets, or we can say folds. So, the first step in the k-fold cross validation technique, that the entire data set is being divided into k-fold number of subsets or k-fold sets. After that, we evaluate we train the model on all these different sets. So, let us understand the process of cross validation, that is k-fold cross validation technique. What is the process? In the first step, we split the data. So, the available data set is divided into k folds, like I said, where each fold contains an equal number of observations. So, in the first step we divide the entire data set into k folds, and each fold contains same number of observations. So, for example, if we have 1000 observations and if we select k is equal to 5, so it means that there are 5 sets, and in each set we will have 200 observations. So, every set contains 200 observations. When we divide the data set having 1000 observations and we select the k is equal to 5, means what? The subset are going to be 5. So, the size of the k fold is 5. So, here each fold contains equal number of observations, that is nothing but 2 observations. So, this is the first step. So, in each fold contains approximately an equal number of observations, like I said, and the value of k is typically selected based on the size of the data set. So, it can be 5, it can be 10, it can be 9. So, it can be any number, but depending on the size of the data set, on the complexity of the data set, the value of k is been selected. The second step is the iteration. The first step is splitting the data, that is, we divide the entire data set into equal number of folds. In the second step, that is called as iteration. In the iteration, for each iteration, that is I is equal to 1 to k, means the model is trained and evaluated using different combinations of training and validation sets. So, here the model is trained for each number of folds, that is k is equal to k minus 1. So, here the fold I is used as the validation set. So, I is used as the I stands for validation set, and the remaining k minus 1 folds are used for training the set. So, here I will train my entire data set for k minus 1 time. So, k minus 1 time will be used as a training data, and whereas the value I is used as the validation set. For example, in the first iteration fold 1 to k minus 1 are used for training and fold k is used for validation. So, in the first iteration, what it happens here, fold 1 to k minus 1 means I am using the fold k as validation, and this process is repeated k number of times, each time with different set of validation sets. So, this process is repeated k number of times. If my value of k is equal to 5, it means that this process is repeated 5 number of times. So, this process is repeated k times, and so that each fold serves as the validation set once. In the third step, the model is been training and evaluated. So, the model is trained on the training set and it has been evaluated on the validation set. The model is trained on the training set using the chosen algorithm and any specified hyperparameters. The trained model is then evaluated on the validation set to measure its performance. So, once the model is been trained k minus 1 times, after that the model is been evaluated against the validation set in order to measure the performance of the model. The performance measures such as accuracy, precision, recall or mean squared error are calculated. So, these are some of the performance metrics. On the basis of these performance metrics, the model is being evaluated, like what is the accuracy, what is the precision level, what is recall or what is mean squared error of this model are being calculated. So, in the first step we split the data, second step we train the data for k minus 1 times. After that we evaluate the model against the validation set in order to measure its performance, like to check its precision, accuracy, mean squared error, etc. In the next step, that is the iteration process, step number 2 and step number 3 are repeated for each iteration. So, for each iteration, step number 2 and step number 3 are being repeated with the different folds used as the validation set each time. Like I said that we train the data by using k minus 1 times. Once it has been trained, we evaluate that model against the validation set, each time with a different validation set. This ensures that every observations in the data set is used for both validation and for training purpose. In the next step, that is performance estimation. In performance estimation, we measure the performance measures obtained from each iteration are averaged. So, here in this step, whatever we have obtained, that is performance measures that we have obtained in the previous step or from each iteration are averaged to provide an overall estimate of the model's performance. So, in this step, what we do, we get the average of the performance measures that we have obtained in the last step. This average performance matrix represents how well the model is expected to perform on unseen data. So, this averaged measures or the average number will represent what it represents. It represents that how well your model can perform on unseen data or unknown data. So, that accuracy, the level of understanding, the level of output will be decided by the average values. So, the average values will represents how well your model is going to perform on unseen data. So, it is based on the average value. That is nothing but the performance measures value that we have obtained, and we get the average of these performance measures, so that we can predict that how well my model can perform on unseen data. The process of k-fold cross validation helps in comparing and selecting the best model or a set of hyperparameters. So, the process of k-fold cross validation helps in comparing and selecting the best model or a set of hyperparameters. And by evaluating the model on multiple subsets of the data, that is training data and validation data, it provides a more robust assessment of their performance. Now, let us see what are the advantages of k-fold cross validation. First, efficient use of data. So, all observations are used for both training and as well as validation purpose, which will maximize the data utilization. So, here I am using the data for both purpose, for training as well as validation. So, this ensures that data is used efficiently. That is the advantage of cross-fold validation technique. Second, reliable performance estimation. So, averaging the results from multiple iterations reduces the impact of randomness in the data that we have split. So, when we average the performance measures, definitely it will reduce the randomness, the impact of randomness in the data split. So, again reliable performance estimation is possible. The next advantage is overfitting detection. So, the model is tested on different subsets of data. So, this will help to reduce the possibility of overfitting your model. Now, how to choose the value of k? The choice, the selection of k value depends on the size of data set, but common values which are used for value of k are 5 and 10, but it can be any other values based on this specific problem. For smaller data sets, the higher value of k may be chosen to ensure the efficient training and validation data in each fold. So, in case of for example, for smaller data size or data sets, the higher value of k is been commonly chosen to ensure the efficient training and validation of the data in each fold. So, that is the common practice. Now, we come to the conclusion of this part, that is k-fold cross validation is a valuable technique for evaluating the model's performance and generalization ability. Basically, k-fold is a model, it is used for measuring the performance of a predictive model, or model we can say evaluating the performance of predicting model. That is the main task of k-fold cross validation technique. It helps estimate how well a model perform on unseen data and aids in model selection and hyperparameters tuning. So, by using the k-fold cross validation, we can we can estimate, or we can say predict how well my model can perform on unseen data, and it will aid in model selection, and again it will help in hyperparameters tuning. By utilizing all available data, that is training data and validation data, it will reduce the impact of overfitting or the randomness of the data set. K-fold cross validation provides a robust evaluation of predictive models. So, this is an example of how we can implement K-fold cross validation using Python. Just look at the code. After that, I am going to explain the line by line of this code. So, just have a look at the code which is implemented by using Python. So, now let us come down to the line by line explanation. The first few lines, so for example, import numpy as MP, from sklearn.model selection import K-fold, from sklearn.model selection import train underscore test underscore split, from sklearn.metrics import accuracy underscore score, from sklearn.linear underscore model import logistic regression. So, here we have imported the necessary libraries which are used for K-fold cross validation. Like I said that the necessary libraries are imported, for example, numpy for numerical computations, numerical calculations, K-fold from sklearn.model underscore selection for performing the K-fold cross validation, accuracy underscore score from sklearn.metrics for calculating the accuracy, and logistic regression from sklearn.linear underscore model as an example model. The next line, that is x is equal to np dot array. So, here we have created the data set with having 1, 2, 3, 4 and 5 data sets, and y as np dot array having we have defined, and we have defined two arrays with the name of x and y. X contains your data set and y contains the target labels. So, data set x is created as a numpy array representing the features, feature matrix, and target variable y is created as a numpy array representing the corresponding labels. So, as you can see that there are 5 labels, each one represents a single data set. The next line defines k is equal to 5, means what? Here I want to divide the entire data set, entire observations into equal number of folds, then those number of folds are 5. So, I want to divide the entire data set into 5 sets. Then kf is equal to k-fold function in the bracket n underscore split is equal to k. So, here I am creating an instance of k-fold with n split set to k. So, here I am creating the object of k-fold with the data set is been split, is been divided equal to k, that is nothing but 5, and this initializes the k-fold cross validation object. Next, accuracy is equal to score is equal to a list. So, here an empty list with the name accuracy underscore scores is created to store the accuracy scores obtained from each fold. So, the accuracy which we are going to obtain from each fold in the iteration, in the for loop, is going to be stored somewhere, and that here we have stored the accuracy that we have got from each fold, each iteration in a numpy array called as accuracy underscore scores. So, the accuracy underscore scores list will contain the accuracy score that we have obtained while we iterate, while we train the model. Next line will define the for loop, that is for train underscore index comma val underscore index in kf dot splits x. So this loop is going to be executed, it is going to be repeated x number of times. So x, as we have seen in the previous slide, x represents the data sets. So here for each data set I am going to repeat this loop, and what this loop will do, that is x underscore train comma x underscore val is equal to, in the square bracket, train underscore index comma x, again list in the bracket val underscore index. Next statement, that is y underscore train comma y underscore val is equal to y of list train underscore index comma y in the square bracket val underscore index. So here a loop is started. To iterate over each fold of the k-fold cross validation. So for each k-fold validation, for each fold, this loop is going to be repeated. That is kf dot split of x splits the data into training and validation indices for each fold. So the data has been split into training as well as validation indices for each fold. Train underscore index and train and val underscore index represents the indices for the training and as well as validation sets respectively. X underscore train and y, that is y underscore train, x underscore val and y underscore val are created by indexing x and y using the corresponding indices. The next line is model is equal to logistic regression, model dot fit in the bracket two parameters that we have used here, that is x underscore train and y underscore train. So here a logistic regression model is been created using the logistic regression function, and the model is trained using the training set, that is x underscore train and y underscore train with the fit method. Then the next statement is y underscore pred is equal to model dot predict, in the bracket I have specified one parameter as x underscore val. So this will predict the labels for the validation set, that is x underscore val, using the predict method. The next line is accuracy is equal to accuracy underscore score, in the bracket I have given the parameters, two parameters, that is y underscore val comma y underscore pred, accuracy underscore scores dot append accuracy. So the accuracy score is calculated by comparing the predicted values, that is y underscore pred, with the true labels, that is y underscore val, using the accuracy underscore score method, and the accuracy score is appended to the accuracy underscore list, so that we can have the list of all the accuracy that we have obtained from this for loop. The next statement is average underscore accuracy is equal to np dot mean, in the bracket accuracy underscore score. Then the next statement is printing the average accuracy. The average accuracy is calculated by taking the mean of all the accuracy scores in the accuracy underscore list using the np dot mean method, and the average accuracy is then printed with the help of a print function. So this code demonstrates how to perform cross-fold validation using a logistic regression model. So with this we come to the end of this session. I hope you have enjoyed this session. Thank you everyone for watching this.